Okay, first thing we're going to do for this lesson is go over your warm-up, which is a great review for your next quiz. So for number one, what we would like for you to do is to classify by the number of terms. It has 3 terms, 1, 2, 3, so it's a trinomial. The leading coefficient is 5 because it's in standard form and it's the first coefficient you see, leading everything off. The degree of the polynomial is 3 because it's the highest exponent, and the constant is 5 because this is the number without any variables attached. Find the difference. So first thing I did was add the opposite. So I changed all these signs and then I combined my like terms, starting with the highest degree, which is 3x cubed. Combining the x squared terms, I get negative 3x squared plus 7x minus 1. Using FOIL, first, outer, inner, last, and then I combine my like terms, and this is my result. This one you're going to need to use a box for, or distribute each of these terms. So you can distribute the 4x to here, here, and here, and the 3 here, here, and here. Then when you combine your like terms, you should get 8x cubed, 8x cubed plus 2x squared plus 25x plus 21. Okay, so the next thing I want you to do is, this is more of the lesson opener portion of this and super duper important. I'd like for you to either use a box or FOIL to find the products of each of these. So here's what I mean. For a plus b times a plus b, if I'm using a box, you have a, b, and then a plus b. A times a is a squared. A times b is ab, a times b is ab. I always put it in order, alphabetical. Instead of ba here, I'm writing ab. And then b times b is b squared. Now remember, your like terms are always going to be on your diagonals here for these. So I'm going to start with a squared, ab plus ab, 2ab, and then plus b squared. And then for the next one, let's do FOIL. So first terms is a squared, outer, I'll go here, is minus ab, inner will be these two, another negative ab, and then negative b times negative b is plus b squared. If you hate FOIL, guess what I don't mind? I don't mind if you box it out, minus 2ab, or use the distributive one, plus b squared. Okay, and for this next one, same thing. Whichever method you like, go ahead and use it to multiply it out, and then press pause while you're working, and then unpause. Actually, let's just do it together. Not that I don't trust you, it's just that I don't trust you. So, I'm in a box. I have a plus b and a minus b, A times a is still a squared. A times b is ab. A times negative b, negative ab. Negative b times positive b, negative b squared. Okay, these are important. This is us. We have just multiplied these out, and what it does is it proves the properties that we're going to be using like right now, actually. So let's see if I can move this down just a little bit. So the first one is special product, a plus b squared. Well, a plus b times a plus b is the same thing as saying a plus b squared, because it's the same thing twice. Whenever I have that, instead of using a box, instead of foiling, instead of using distributive property, I can go straight to this property, which just tells me I can square the first term, add 2 times a and b plus b squared. How does that work? Well, we just showed it, because that middle term is going to be this times this, so ab and ab plus 2 of them. So it's 2 times whatever this product is. And then for a minus b squared, it's kind of the same thing if you're looking at it, because this was a minus b squared. And it's the same thing as this one with one difference, minus 2ab instead. The only thing that changed was this. Because we squared and we squared, this is the only thing that ends up being negative, because this will always be positive, always be positive. So this is always going to be a plus sign there. And then you have your sum and difference one, and that is going to be a plus b times a minus b. Oh, my bad, I didn't finish this. This is a squared. ab minus ab, well, that's 0ab. So that kind of cancels each other out. And so what I'm left with is minus b squared. This is a very, very special product. You'll use this a lot. So a plus b times a minus b equals a squared minus b squared. Very important. So when you have a binomial, and you're squaring a binomial, you should end up with 3 terms. 1, 2, 3. If you have just your sum and difference deal, sum and difference pattern where one is plus and one is minus, plus and minus, you're going to have a squared minus b squared. All right, let's try one out. So with this in mind, and I'm going to tell you that the only thing that gets kind of confusing with this is remembering which pattern to use. So I'm going to invite you, strongly encourage you, to write the pattern that you're going to be using above or near the problem so that you can make sure that you're plugging in correctly. So here's your first one. X plus 9 squared. This is the square of a binomial. So we're going to use this pattern, a plus b squared, and that was equal to a squared plus 2ab plus b squared. So for this problem, if you look at it, kind of lines up nicely. This is your a, and this is your b. So in this, wherever I see a, I'm going to write x squared, and then wherever I see a b, I'm going to write 9. So plus 2a is x, b is 9, plus b squared, 9 squared. Then simplify. X squared, 2 times x times 9. Well, what's 2 times 9? 18, but leave the x. Then 9 squared, 81. There you go. Now eventually we will skip this step and kind of just do it in our head, but it's super duper new, so I'm going to show it out. Your next one. This one is a minus b squared. So this is going to equal a squared minus 2ab plus b squared. You'd get the same thing if you FOILed it out, get the same thing if you boxed it out, same thing if you use the distributive property part of it. But this will be faster as soon as we get used to it, so build up your endurance, and then you can skip this step and you'll go straight from here to here once we get some nice good practice. But for now, let's show it. So this is, here's what I'm going to do. A squared minus 2ab plus b squared. This is a, b, and then this is b. So a is 3m minus 2a is 3m, b is 5. It's not negative 5, b is 5. So don't put a negative here and a negative here. Why? Because it's already accounted for right there. Just like in this slide. It's not minus 2a times negative b. This negative sign is already out here in front, so don't double replace it. It'd be a bad situation. And then b squared is still just 5 squared. Okay, so remembering 3m squared is not 9m, and it is not 3m squared. You have to square both of these. So squared and squared, it's going to be 9m squared. And then minus 2 times 3 is 6. 6 times 5 is 30m. Check my math. 5 times 3 is 15 times 2 is 30. And then plus 5 squared is 25. There you go. I know I'm taking a really long time to explain it, but it's just because I want to make sure that you have it. Okay, you feel good? Press pause. Try this one solo. Or try it in your head, because here's what you're doing. A squared. So here's your A, here's your B. Your pattern is a squared minus 2ab plus b squared. If you memorize these now, I promise you your life will be so much better in your future classes. Okay, so here's me thinking, and if you want you can press pause and go solo. A squared, this is 2 squared, so that's 4. Y squared is y squared, minus 2ab. So 2 times 2 is 4. 4 times 3 is 12. And the y is still there. Plus b squared, so 3 squared, 9. And that's your answer if you do it all in your head. If you showed your work, I got that from 2y squared minus 2 times 2y times 3 plus 3 squared. Love it? Hope so. Okay, A plus B. Remember your pattern. Just writing it, I promise you, I know it's tedious, but it does kind of help. Okay, square the first term, and this has fractions, so I'm not going to try to do this in my head, actually. 4r squared plus 2a is 4r, b is 1/2, friendly fraction, I like it, plus 1/2 squared. 4r squared, 4 squared is 16, r squared is r squared, plus 4 times 2 is 8, 8 times 1/2, so here's me, 8r times 1/2 is 4r. And then plus 1/2 squared. 1 squared is 1. 2 squared is 4. There you go. All right, let's keep it pushing. Sum and difference pattern. So this means 1 is the sum and 1 is the difference. That's a subtraction. And that equals a squared minus b squared. This one is way user-friendly. That's why I saved it for later. What you do for this one, beautiful people, is you take the first term and square it, and you subtract that from the second term. I'm going to tell you it doesn't matter which one is plus and which one is minus. So this is your a plus b, a minus b. And so what matters is this is a and this is b. This is equal to a squared minus b squared. So what's the a? 2d. What's the b? 7. 2d squared is 4d squared, squaring each of these terms, minus 7 squared is 49. Yeah, people tend to like this one like heck more. For this one, it's still sum and difference, even though it's difference and sum. No one cares because multiplication is commutative. And so we're going to have x squared minus 4y squared, because this is your a, b, x squared is just x squared minus 16y squared. Like it? I love it. Try C and D on your own, and I will show you my answers. Yep, there's a fraction there, but it's not a bad one to deal with. And for C, you have v squared minus w squared after you square each term. And then for D, 1 over 4k squared minus 3 squared gives you 1 over 16k squared minus 9. That 1/4, don't forget, is just 1/4 times 1/4. So 1 times 1, 1, 4 times 4 is 16. All right, thank you kindly. This was Special Patterns, and hope you enjoyed it. Have a good one.